Hello there, more transformations in 3 dimensions and exercise 3E again, a second chance. You'll notice I've got a teapot by the looks of it there, and it's being transformed in a variety of ways. And I suppose, one thing we don't do is translations, interestingly. We don't have to on our course. I just need to turn my pen on. We don't do the translations. The two that I've said we are going to do, we're definitely doing rotations. And the other ones that I want us to be able to do is reflections. And they are basically the two parts of the course we need to be able to do. And it doesn't have to be 90 degrees, by the way. We saw last time, I think, 180 degree rotation. And the key, I suppose, today as well is looking at determinants. So that was a summary of what we saw last time. I won't dwell on that too long. We might come back to it in a bit. It says transformation S represents a 60 degree rotation about Y. Write down the 3x3 matrix. Well, it should be fairly easy. What's it say? It says a 60 degree rotation about the y-axis. So remember, these are in the formula book, so this is not rocket science. We're just going to write this down, and it says cos theta naught sine theta. I think it said. Let's just go back. Yes, 0, 1, 0. And then you'll just notice the minus creeps in and they swap places. And that was a cos theta. I assume it was a 0 in between. Yes, it was. So that's my matrix for S. And of course, all I've got to do is chuck some numbers in there. So it's a 60 degrees rotation. So I want cos 60, 0, and sine 60. 0, 1, 0, minus sine 60, 0, cos 60. You can't get much easier than that, can you? Cos of 60, he says, making sure he gets this right, is a half. Then it's 0, and then root 3 over 2. 0, 1, 0, minus root 3 over 2, 0, a half. So if that's true, let's just check the answer, and that looks right then. So point A is transformed by 90 degree rotation about the x-axis. Again, I suppose I'm just going to go back. It says the x-axis this time, so it's not the same, apart from the 1 now is up there, cos minus sine. So the minus now is up there. So I can remember that. So the A has got to be, oh, that's the point, isn't it? My matrix has got to be 1, 0, 0, 0, 0. And I said I could remember, then I've got, so cos minus. So this is cos of 90 minus sine of 90. Sine of 90. And cos of 90. That's easy enough to work out. That is 1, 0, 0, 0, 0. Cos of 90 I know is 0, so they are both there. Sine of 90 I know is 1, so it's minus 1 and 1. Now, it says the point is transformed, and the point is 3, 2, 1, so if I times it by 3, 2, 1, this implies that that times that is going to give me, no, the image, well, that was close. The image is that. So this 1, 0, 0, 0, 0, minus 1, 0, 1, 0, times by x, y, z is equal to 3, 2, 1. Good job I checked that, because this bit here was wrong. So that times that equals that. So of course I use the inverse matrix to do that. X, Y, Z is, well, I could just use my common sense. And you could think to yourself, well, if I moved it back the other way, 90 degrees, I could work out what it is. It might just be easier just to type this into your calculator. And see where it goes, because I suppose there's a danger you'd end up doing it in the wrong direction. So you notice I front multiplied it. I'm going to type it into my calculator. I've got my calculator in hand, so I have. Oops, did I drop it? So I've got to just type these in, so it might take a couple of seconds, bear with me. Okay, so I've typed them in. This has gone into, well, I put it in define matrix A. This 3, 2, 1 has gone into B. So what I'm going to have to do is I'm going to have to say A to the minus 1 times by B. So I'm going to do that now. Matrix A to the time, minus 1 times by matrix B, and I get the answer. And I'm pleased you've got similar numbers, because that's what I'd expect. It's 3, 1, minus 2. 3, 1, minus 2. Let's see if that's right. Yes, it is. Now, notice that they first start wrote it as a coordinate, which of course is what you should do. But if I just draw a picture of this, so depends which way you want to do it. Which way shall we do it? And your picture doesn't matter which way around you do it, as long as you're consistent then. So I'm going to do X, Y, Z. And I like doing it because a couple of times they've given us different ways of drawing it, but they could draw it anyway in the exam. So anyway, if that's my points, where would my... Now notice they said it ended up as 3, 2, 1. So that's 3 going this way, 2 going this way, and then 1 up. It's quite hard to imagine that. And they said we're going to rotate it about the x-axis, 90 degrees. Now, so this is my x-axis going this way. And so you can imagine things rotating in this direction. And we're rotating it 90 degrees. And notice, therefore, the x value, 3, has stayed the same. 3 hasn't changed. So, and that sounds about right. So how far across it is, it strikes me that should stay the same because I'm rotating it around there. So the x-axis not changing is good. I reckon then remember this is where it was meant to be. It was meant to be 1 across, and again it's the answer. No, was it? Yes, it was 1. No, it wasn't. What was it? It was 2 across. There we go. It was 3, 2, 1. So it was 2 along in this direction, 2 in that direction. And when I've rotated it 90 degrees, it is now that 2, because it's rotated, it's gone down that way, and it's now 2 below in the z-axis. So it was 2 that way. As I rotate it, it's now 2 down. And that's shown there. And the last point was 1 in the z-axis. That was 1 up. Now as I've rotated that, I think that 1 has just kind of gone and gone into the y. And yes, it has. But it's much easier if you're not having to rely on this, of course, like your imagination and your ability to think in 3 dimensions. It's much easier just using the maths. So the inverse matrix sorts it out for us very nicely. So in this example, we've got a 3 by 3 matrix of a resulting transformation that we want to find, where the 90 degree rotation about the x-axis is followed by a 90 degree... Okay, I see. So we've got some coordinate, presumably, and we don't know what it is. And we are going to do something to it. We're going to do find the resulting transformation when we rotate about the x-axis, and then we follow it by the y-axis. Now you should remember you do these in a reverse order. So just remember these are my rotations. The first one I'm going to do to it is about the x, but then because you do these in a backward order, then I do the y. So I'm going to do those and just multiply them together. Let's see what I get. So this is the x, and it's 90 degrees. So it's 1, 0, 0, 0, 0. They're the easy ones. Cos of 90 is always 0. And sine of 90 is 1. So that's those ones. And that's my rx. My ry, I do a very similar thing. Cos of 90 is 0. So anyway, I've got that. I get zeros. I've got this 0, 1, 0, 0, 0 bit anyway, and it's just these top corner and bottom corner. So sine of 90 is 1, and that's minus 1. So if I just multiply those together, I will get it, the resultant transformation. So just doing this in my head, I reckon that is 0. Probably lots of noughts here. That's a 1, I think. And 0. I bet this is a 0 as well. Yeah. So it's, on my gut feeling, there'll be 3 1s. It's just working out where they are. So now it's that. I think that's a 0. I think that's a 0. My suspicion is this is a 1 or a minus 1. It's a minus 1. And times that one, that's a minus 1. I bet the other two are all 0 zeros. So I think that's the answer. Let's see what I've got. 0, 1, 0, 0, 0, minus 1. Yeah, that's the right answer, so we agree with that. A little couple of points about the determinant. For a 3D matrix, just be aware that the determinant gives you the scale factor. We saw that before. So we saw that, we said the new volume in this case rather than area will be the old volume times by the determinant. That's really the formula we're going to use. But if it's negative, it changes the orientation, and by the orientation it's kind of like the direction in which you would label your points. So it's the equivalent of a reflection, I suppose, but it would just kind of be flipped round. So here's an example. The matrix here is used to transform the cuboid to those find the volume. Right, now first of all, I suppose you could quite easily just say to yourself, what would the volume of this cuboid be? And it's 3, 0, 0, it's 3 wide. I'm assuming this is x. I'm assuming this is y, 0, 2, 0. In fact, I'll do that as 2 high, and then z's going back, that's 4. But one way or the other, you'll see that's 12, that's 20. The volume initially of this shape is 24, whatever. So it says in centimetres, cubic centimetres. So if I want to know the new volume, I just need to find the determinant of this matrix. It will be 2 lots of 3, 3, 5, 0, minus 1 lot of 0. I hope that you can now do this quite comfortably. Plus a minus 1 times by 0, 3 minus 2, 5. Just work that out. It's 2 lots of 0 minus 15 minus 1 of 0 minus a minus 6. Very easy to go wrong on that. Minus 1 lot of 0 minus a minus 6. So this is negative 30. This is plus 6, but it's still minus 6. This is plus 6, still minus 6. I reckon it's minus 42. So I reckon the new volume is going to be 42 lots of 24. Now technically it's minus 42, but I don't think I care too much. Let's go into that. 42 times 24. I think it's 1008. Not a bad number. 1008 is the right answer. There we are. And now that I've got an exam question for, I'm not sure if I've got time to go through it, or if need be we'll do it in lesson. Well, a transformation is represented by the matrix, and there's lots of algebra in there. A tetrahedron, OPQR, has volume 6. The new, a tetrahedron, by the way, is one of these. It's like a triangular based pyramid, so it's a 3D shape. I suppose I should make sure that we know that. So it's got a volume of 6. We've got the new coordinates here. In the case where x is 5, find the volume. Okay, so with that as x is 5, it's minus 1, 5, 2, 2 minus 6, 1. I'm just chucking 5 in for x, minus 5. 5 minus 25, and 10. So I need to work out its determinant if I'm going to find out its new volume. So the determinant, and I might just pause this because I'm running out a bit of time, and then I'll come back to you. So I've written out the matrix, the determinant calculation, minus 1 times this, well, it's plus minus 1 times this, minus 5 lots of this, and plus 2 lots of this. I'll now work them out. So I've done that. I've got minus 1 lot of, that's like a plus effectively, so that's times by minus 35. Minus 5 times 15, that's easier to do. There's lots of minuses to go wrong on this, so that's any problem. And that's like a plus 30, so that's like a minus 20. So minus 80, I get in my head there quickly. Now, so what's that tell me? Find a new volume. Well, the new volume will be 6, the old volume, times by this 80. Notice I didn't care about the negative. 480 is the new volume. And the orientation, because it is negative, so because the determinant is less than 0, therefore the orientation does not stay the same. It is not preserved. Now we're not going to manage to finish it all, so there's the answers and there's the questions we'll finish off in class. Okay, thank you.